to our newest episode of The Grid, a webinar series presented by Quantic Electronics, connecting engineers on the newest technologies and developments in the electronics industry. Today's topic is how patented ceramic gap capacitors will disrupt the RF and microwave industry. My name is Scott Cooper, and I am the General Manager of Quantic ULEX and UTC. I have the privilege of presenting this important and exciting topic, and to share with you the amazing advancements we have made at Quantic ULEX. Unfortunately, Alex Moalemi, co-founder of Quantic ULEX, is unable to be here today, so I will be the sole presenter. However, let me give you just a couple of quick notes about Alex, since he is one of the driving forces behind Quantic ULEX. Alex has spent his entire adult life in the electronics industry, and specifically in passive components. Alex has worked in all areas of passive component manufacturing, from R&D to design engineering to operations and testing, as well as customer support. Alex holds patents for some of his innovative designs and has worked for several capacitor companies, as well as starting his own company, ULEX Components, now known as Quantic ULEX. Today, we will talk about one of Alex's patented designs, the ULEX gap capacitor. In this webinar, we will talk about Quantic ULEX, the company. We will then discuss the industry, conditions that led to the innovative development of the ULEX gap capacitor. Next, we will review the single-layer capacitor, including its benefits and limitations, as well as a few attempts to replace the SLC. Finally, we will introduce the patented ULEX gap capacitor and explain why this is a superior solution to any existing alternatives. Quantic ULEX was originally founded in 2019 as ULEX Components by two highly experienced capacitor engineers, Alex Moalemi and Ewan Armstrong. The inspiration for creating this new company was to replace the single-layer capacitor with new technology. After several iterations, this was achieved, culminating in a patented design in 2021. Quantic ULEX is located in Monterey Park, California, in a 30,000 square foot facility with a brand new Class 10,000 clean room and new state-of-the-art build-up equipment. We manufacture ceramic capacitors that are ideal for high-frequency microwave applications and are also extremely well-suited for 5G applications. Our designs are among the smallest footprints in the industry while maintaining a wide range in voltage that no other components can achieve. The ULEX product line will support a range of 6.5 to 100 gigahertz, with current offerings fully tested up to 50 gigahertz. These capacitors also have a temperature range from negative 55 C to plus 125 C. Single-layer wire-bondable ceramic capacitors have been the industry standard. However, there are a variety of limitations to this form of capacitor. Listening to customers describe their frustrations with these limitations is what drove Quantic ULEX to develop a solution to these issues. High-frequency applications have adapted their systems to accommodate the single-layer capacitor restrictions, but there is no longer a need to do that. The ULEX gap capacitor was designed to adapt to existing systems, allowing for more freedom of design and improved performance of the overall application. Out of all the capacitor technologies, the single-layer capacitor is the closest thing to an ideal capacitor. Because of its simplistic design and monolithic build, the SLC has very low loss. This low internal resistance loss, or low ESR, combined with very high self-resonant frequency, or SRF, makes them extremely useful in high-frequency circuits. This is why SLCs are so widely used. However, there are drawbacks to using SLCs which makes this ideal capacitor not so ideal. The traditional single layer capacitor really is only a single layer, so capacitance is largely dependent on the dielectric constant of the materials used. Manufacturers overcome that limitation to some extent by developing an expansive selection of dielectric materials, or dielectric constants, that go higher and higher in capacitance. As we go up the dielectric constant scale, there are trade-offs such as temperature stability, voltage coefficient, and a decrease in the Q of material. In fact, selecting a material for an SLC design can be somewhat overwhelming, and with dozens upon dozens of dielectrics to choose from, each with its own specific performance characteristics. How are these products physically used in a circuit? Rather awkwardly, in fact. These capacitors don't lend themselves to surface mount techniques that we've typically used in the past. However, the industry has come up with a solution: wire bonding. Typically, one conductor of the device is die attached to a circuit board, pad, or strip line, and the top side is wire bonded to another part of the circuit. Wire bond has its own issues, though. One issue is the expensive equipment required. Second, it is not always that easy to wire bond surfaces at varying heights, or in a device with some topography, as anyone who has done that work will tell you. In addition, there are reliability issues, and as we move to higher frequency, there is an issue of the bond wire contributing to loss in the system, directly affecting performance at high frequencies. So, what else can be done? We've seen a number of ways customers have tried to circumvent the wire bond and incorporate the SLC capacitor into the circuit, either because there is no wire bonding capability available, or because the customer is looking to eliminate the loss from the wire bond itself. These alternative methods include attaching tab leads to the SLC and soldering the tabs to the strip line, or simply standing the device on end and soldering it to the strip line. In doing this, the soldering can be difficult, inconsistent, and frankly, quite messy. The truth is, neither of these techniques is perfect, and they both add cost and complexity to the assembly, not to mention the additional height required for the chip to be stood on end. Moreover, these techniques do not address the capacitance limitations of the SLC design. A number of companies have developed gap capacitors under various trademark names. Gap capacitors are essentially two single-layer capacitors in series. The device is soldered or epoxy mounted to the strip line, completely eliminating the need for wire bond. The width of the devices are typically designed to match standard strip line widths and are an excellent solution for both strip line and coplanar waveguide designs. However, just like the alternative methods we discussed in the previous slide, these devices do not overcome the capacitance limitations of the SLC. As a matter of fact, these devices exacerbate this limitation, as the series capacitance generates a value C/2, or half of the original SLC device being replaced. The added complexity of the second metallized surface and the configuration of the electrodes moves these devices further away from the ideal capacitor configuration. Enter the ULEX gap capacitor, a solution that addresses all of these issues. The patented ULEX gap capacitor has a novel internal structure that produces a true single-layer capacitor, not a series circuit, in a device that can be flip chip or surface mounted. This configuration completely eliminates the need for a wire bond and provides a device with extremely low ESR and high SRF. and the configuration of the electrodes generates more capacitance from the same dielectric material. Let me say that again. ULEX is achieving more capacitance from the same dielectric material. This gives the ULEX gap capacitor some distinct benefits. As you can see in the table shown, using the same dielectric material at the same voltage, the ULEX capacitor can achieve much higher capacitance compared to competition by a factor of 10x or 20x or even more. In addition, at low voltages like 16 volt and 6.3 volt, where the ULEX gap capacitor provides excellent results, the competition does not even have an offering using these dielectrics. In covering this wide range of performance characteristics, the ULEX gap capacitor not only becomes a better option, in some cases, it becomes the only reliable option. You can see the ULEX gap capacitor has many clear advantages as listed on the slide. Let's explore a few of these advantages in greater detail. As we just discussed, the patented structure allows for up to 20 times capacitance over competitors' designs. This capacitance advantage means you get more performance out of the same footprint. The ULEX gap capacitor also uses only 3 dielectrics to achieve the full range of capacitance compared to competitors who require up to 26 different dielectrics for the same range. So, we can cover the full range of performance requirements with 3 dielectrics compared with 26 from others. This also means you can move away from the unstable performance of GBBL dielectrics by using our patented design gap capacitor. Not only do we limit the dielectrics required, the ULEX gap capacitor does that while keeping temperature stable, while keeping voltage stable. The elegance of this design is its simplicity, which yields higher performance with a reliability that the alternatives cannot match. Another advantage of the ULEX gap capacitor is that it can be produced in dimensions to match the width of the strip line in whatever application you have. By doing this, we gain maximum performance of the capacitor for your board or assembly. The ULEX gap capacitor removes the need for wire bond, which, as we already discussed, is one of the limitations of the single-layer capacitor. However, for those of you with locked-in designs and structures where wire bond is necessary, you can still use the ULEX gap capacitor because the pads are, in fact, wire bondable. If you need direct connection between integrated circuits, this is still your solution. With this much performance improvement, you would expect these parts to cost significantly more than the alternative capacitors. However, due to the efficient design of the ULEX gap capacitor, manufacturing costs are lower than standard gap capacitors. That translates into lower costs to our customers. Beyond all of the advantages I just described, the ULEX gap capacitor construction eliminates partial shorting since there are no electrodes on the top of the component. It is RoHS compliant, meaning it is much more environmentally friendly. And it is customizable, meeting a variety of size and capacitance requirements. When it comes to capacitors, one of the most important elements, quite obviously, is performance. For anyone that has to make a decision on which capacitor to use or purchase, these charts will likely look familiar. These are the standard performance graphs used in the industry, generated by a highly regarded independent testing service, Monolithics. What you see here is that the ULEX gap capacitor not only performs extremely well at very low frequency ranges, but also maintains that excellent performance at higher frequency ranges. In fact, a test performed on the ULEX gap capacitor at another Quantic facility called X Microwave shows that performance has very low loss, even out to 67 gigahertz. You will notice in this real-life application, the ULEX gap capacitor performs very well, showing a steep entry curve on the left-hand side of the graph, meaning we have less than 5 dB loss even at 1 gigahertz. On the right-hand side of the graph, you will see that even at 67 gigahertz, the loss is 1 dB or less. The ULEX gap capacitor maintains its high level of performance throughout the entire frequency range. And we are not talking about theoretical performance estimates, but actual test verified performance. You can see the data for yourself. What is the best application for the ULEX gap capacitor? Well, if you're listening to this webinar right now, and thank you, by the way, for attending this webinar. I appreciate you taking the time to be here. There is a very good chance you already know the answer to that question because you are probably in the industry. However, for the sake of thoroughness, I will tell you that the ULEX gap capacitor is an excellent fit in the photonics industry, in the optical networking industry, including ROSA and TOSA. These capacitors have applications in the 5G and high-speed data market, the broadband market, and others, as you can see listed here. Specifically, the ULEX gap capacitor is used for DC blocking, coupling, RF bypassing, filtering, and tuning. There is a clear and distinct advantage in using the ULEX gap capacitor for these applications. Here is a bit of a teaser slide. Although we do not have the time to review these alternative configurations in great detail, I do want to introduce the versatility of this product. We have spent much of the time in this webinar describing the use of the ULEX patented gap capacitor as a superior alternative to standard gap capacitors. Therefore, I will not review those advantages again right here. Instead, let's review some other ways in which this product can be used. When mounted upside down or in the flip chip configuration, the ULEX gap capacitor can be used as a binary capacitor. In this setup, the ULEX gap capacitor can be wire bonded to integrated circuits and supply the 10x or more capacitance than the competition. In addition to this, in this flip chip configuration, not only can this component be used as a gap capacitor, but also each pad can operate as its own single layer capacitor. That means you actually get 3 capacitors in one using the binary capacitor setup. With a 2-pad capacitor, you have the standard but higher performance gap capacitor connection and 2 single layer connections. As you extrapolate this forward, it means we can get even more connections from one ULEX gap capacitor to feed your various other integrated circuit requirements just by introducing more and different size pads. Just think of the possibilities. The next configuration is the broadband block. In this setup, we mount the ULEX gap capacitor to a high capacitance multi-layer ceramic capacitor, or MLCC, which, by the way, we make at Quantic UTC, located in the same facility. This generates a high-performance broadband block that is the lowest profile in the industry, with extremely low insertion loss and available in a variety of sizes down to 0201. As you can see, this amazing ULEX gap capacitor can adapt to many different requirements across multiple applications. As we begin to wrap up this webinar, let's review the information provided in this presentation. We have shown that the ULEX patented gap capacitor provides the benefits of a single layer wire bondable ceramic capacitor, but without the limitations of the SLC. We demonstrated that the simple and efficient design of the ULEX gap capacitor results in increased capacitance and frequency performance compared to the competition. With dielectric optimization, the ULEX gap capacitor covers the full range of capacitance using 3 dielectrics, while others require up to 26 dielectrics to cover the same range. In addition, this coverage comes with temperature and voltage stability. We viewed the performance charts that show that the ULEX gap capacitor is effective and has extremely low loss at both very low frequencies and high frequencies. We covered the fact that the novel design of the ULEX gap capacitor allows for low manufacturing costs, and that translates to lower pricing to customers. Simply put, the ULEX gap capacitor meets the demanding requirements of high-frequency applications such as 5G, microwave, and millimeter wave systems.
Thank you, Scott. All right, at this time, we'll welcome any questions. If you'd like to put them in using the Q&A button or the chat below. I did have a couple come in, Scott, during your presentation. The first one being, are you working on something equivalent to the millicap from Dielectric Labs?
Yes, good question. In fact, we are working on the same equivalent part numbers as the millicap. In addition, we're also working on the equivalent of the ATC 500S series parts as well. So those are definitely coming.
Great. Another one, when and how can we get a sample kit of the ULEX gap capacitor for our own testing?
Yes, this is probably one of the most frequent questions that we get. We are actually working on those right now, and sample kits will be ready to order directly from our website or from DigiKey by the end of May. So you will be able to find those and purchase your sample kits at that time.
Okay. Any reliability testing performed on the ULEX gap capacitor?
Yes, another great question. Obviously, with any components, you want to verify their reliability. So we have a minimum of 3,000 hours life test for all our dielectrics at 125C and 2 times the rated voltage with no failures so far. So we've proven out the reliability of these components and have that data available.
Great. Another question, are there data sheets available for this product? And if so, where can I find them?
Yes, again, having the data for these components is a crucial part of the reliability. So we have all our data sheets available on our website, www.quanticulex.com, and you can find them there. In fact, there's a whole host of information on the website available to you that talks to the performance of these capacitors.